Hi, welcome to my first ever computer programming YouTube video. And since this is my first video on YouTube, I thought I would start with a fairly simple topic on dynamic arrays. I plan on making more videos on data structure implementation and algorithms. And this is mainly towards students who are in the algorithms or data structures course. So today's video is on dynamic arrays, and we will go through the explanation and theory. So the difference between a dynamic array and a static array is that static arrays are created onto a stack and do not require memory management. They are destroyed once the function they are in is completed, or you can think of it as when the function is no longer in scope. And what that means is, say you have a function that adds two numbers, integer a and integer b. Once that function is completed, those two integers a and b are removed from the stack and are no longer used by the memory. So you can't use them anymore pretty much. And a static array has a predefined size. For example, integer a, 10, meaning you're creating an integer array of size 10. Now, with a dynamic array, and I have here not to be confused with a dynamically allocated array, has a infinite size. And I put a little asterisk here because it's infinite in terms of how much computer memory you have. If you run out of memory, then obviously the array can't grow any larger. And the array grows as more space is needed. And you could think of the vector class in C++ or the array list in Java. And one more point I want to mention is dynamic array is not to be confused with a dynamically allocated array. What I mean by that is a dynamically allocated array is an array that you create by taking memory from the heap in order to create it and not using the memory on the stack. So that's different from a dynamic array, which is the array that grows as more space is needed. If you are still confused by that distinction between two, you can do a Google search and you'll probably find a better explanation. Moving on. So why would you want to use a dynamic array? I've touched this before. It's not limited to a defined array size. As in the previous example, we have integer a is 10, so the array size is 10, and we can't make it any larger. We only have 10 indexes, or 10 slots, I could say. So, also with the dynamic array, we can insert. We have the insertion and removal functionality, meaning that we can remove things from the array completely, and we can also insert into the array at the end, the front, or pretty much anywhere you want. And with the stack array, you can pretty much insert where you want, but that would overwrite the thing at the current location. So if you want to insert something in the beginning of the array, for example, in the dynamic case, that'll be fine. Everything will be shifted over. But with the stack array, say a at 0, it has the integer 5. You want to place a at 0. If you wanted to place, say 9 at a at 0, that would overwrite 5. So you aren't really inserting, you're actually kind of replacing. So with a dynamic array, you have the ability to insert and remove. And you still have O1 accessing time complexity compared to a regular array. Meaning getting something from the array, say whatever is at location 5 of the array, will require the same amount of time as using a static array. And if you're unfamiliar with this O1 it just means big O of 1, meaning it's a constant time. So no matter how big your data set is, or in our case, how big our array is, getting something at a certain location will always require pretty much the same amount of time. So cons to using a dynamic array. It can potentially use up a lot of excess space, which means that, say we only have 5 elements, but in actuality, our dynamic array has a capacity of 10. That means you have 5 unused spaces, and that it's pretty much taking space. And that's a small case, because what if you have, say, 2 items, and now, but the capacity is 20, you're wasting 18 spots, or spaces. So, it can potentially take up a lot of space. And removal and insertion at certain indexes are costly operations. And what I mean by that is, if you wanted to remove something from the array at a certain position, or insert at a certain position, we would have to shift things over left or right. So that would require n time, linear time, on average. Actually, on average it's n over 2 time, but in a big O case it'd be O n time. So that is costly. And so if you know how much size you need beforehand, it's better just to use a regular normal static array in that case. But a lot of times you don't know the size limit beforehand, so this is why array lists and vectors are useful. And so in today's video, we will be implementing a dynamic array in C++. And I have here implementation theory is pretty much the same with Java or another OO language. So if you're using Java or another OO language, the theory behind how you implement it is fairly the same. But like I said, in this video we're going to use C++. And we will have our dynamic array holding integer data types, because this makes the implementation and demonstration testing fairly simple. But like, you can always have pretty much any data type you want, especially if you use something called generics. And we will double the capacity of the array when the capacity is reached, meaning we will double the array size whenever our array reaches full capacity. So if our capacity is 10, for example, and we have 10 items in our array, we'll double it to 20. We'll double the capacity to 20. Now, what I mentioned before with taking up a lot of excess space, so if you had, say, two items, but your capacity is 20, you're wasting 18. So what we're going to do is we will shrink the capacity by half whenever the number of elements in the array reaches floor capacity over 4. So let's say our capacity is 10, and we only have 2 items in the array. So if we take 10 divided by 4, that's around 2.5, I think. So if you pull that, you would get 2. And so 2 is equal, that's equal to 2, which is the number of elements in our array. So we'll cut the capacity by half. So we'll reduce the capacity to 5. So now instead of 2 items in a 10 capacity array, we have 2 items in a 5 capacity array. So we're taking up less space in this case. Now, to make the implementation easier, we're only going to include a few methods. Adding, and in our case we are going to include adding at a specific index. We're just going to add at the end of the array. Removal, and we are going to be removing by integer value if it exists in the array, and not by index. So say we had an array with values 1, 2, and 3. You would be able to remove 1, 2, or 3 based on value, but not at indexes. So say 1 was at index 0, and you try to call the function remove 0, it would not work because there is no value of 0 in the array, because we're not removing by index, we're removing by actual value. Searching. So we will have a searching function that allows us to search to see if a certain integer value is in our array. And if it is, we'll return the index location. Otherwise, we can return -1. And then we will have accessing/indexing, which is getting the value at a certain index, like the array list get method at some index, or the vector with brackets of index. And then we'll also have a printing function to display what's inside the current array, and a function to get the number of elements currently in the array, or the size, such as when you call the vector.size function or the ArrayList.size function. Before we write code, I'm assuming you are aware of data types and classes, object-oriented programming. So, and I'm assuming you are aware of what data structures are. Alright, so let's implement our dynamic array. So like I said, we're going to C++ in this video, and so we will need to create a new project. I'm using CodeBlocks IDE, but you can use any IDE you want. You can use Notepad. Okay, so we will need 3 files: a header file, one .cpp file, and then a main.cpp file to run and test our dynamic array class. So one header, call it dynamic array. We'll add it to our project here. The second CPP file is for the function implementation. And then we need one main class. Let's call it main. Just want to make sure that they're at the right place. Alright. Oops. Haven't used code blocks in a while. So in our header, we define our class, dynamic array. And then we will have public for our class methods and our constructor. So we will have a default constructor, and then under private we have our data members. Private, and then so for our data members, what we're going to need is a variable to hold the size or the number of elements currently in our dynamic array, integer capacity for the actual size of our dynamic array, or the capacity of it, how many elements it can hold in total, and then a integer pointer that will point to our array. If you're unfamiliar with what a pointer is, it pretty much points to a memory location in your computer. So what this pointer will do is point to the memory location in our computer of where our array is. And I can make a video in the future to explain this better, but for now that's all I'm going to say about that. Alright. Now for the class methods that we mentioned in our implementation plan. So we said we were going to add a getSize function, add at the end of the array, removal by integer value, searching to see if an integer value exists in our array, a accessing get function to get something at an index, and then a print function that will display to the console what's in our array. So integer get size. So these are function prototypes. So there's no implementation in our header file, but you could, if you wanted to put the implementation in the header file, then you no longer need this file, but I just like doing it this way. Okay, so the first function, the getSize, it's going to return an integer, and it's going to return this data member here, and we can't just get it from like outside of the class because we have it under private. And then the second function, void, it returns nothing. It just adds whatever integer value we pass here into the end of the array. Boolean, remove integer. So for this function, I'm going to make it a Boolean type so that it returns true when it does remove whatever you passed in as the parameter, and it will return false whenever the parameter you passed does not get removed because it was not in the array. And integer search. So this function is going to return an integer type, and what it will return is the index of the integer parameter you pass here. And if it can't find it, then it will return -1 in our case. And then integer get, this will just get the integer value at the index passed in here in our array. And then finally we'll have a print function that will just display the contents of our array. So we can have that as a void return type. So now for our default constructor, we'll set size to 0 because when we first create it, there should be no items. And we'll set, now this option is pretty, it's up to you, but the initial capacity. So in our case, I'm just going to strict 10. But you can pick whatever you want. So what this means is our array initially will have a size of 10. Now we need to create the array, the initial array. So we set the pointer to point to a new integer array of size capacity, which we have set as 10. And this is what I mean by dynamically allocate array previously. You create the array using memory on the heap. So that's why we use this new keyword here. And before I move on, I just want to make sure that there are no syntax errors in my header file. So we'll compile this and see what happens. Okay, cool. So no compiler error. Good. Alright, now we will have to implement these methods that we have here. So we will start with the easier ones, I suppose. So hashtag include. So we're gonna include some libraries here. IOStream for console output. Well, I'm gonna include this too, and I'll explain why later. And we will need to include our header file. Okay, so let's first implement the get size function because that's fairly simple. I'm assuming you know how to create classes in C++, so I won't really talk about the syntax here. So for our get size function, all we do is return the size. That's it. It's very simple. Let's add some comments actually. I like writing comments on my code. Return function returns number of elements is the array. Okay, so now let's implement our add function. Add integer into the end of the array. So this was a void function. We'll say integer to add. Is that a typo here? No, typo. Okay. So the value passed here to add will be added to the end of our array. So what we should do initially is check to see if our array currently has reached the maximum capacity. So check if the array capacity has been reached. So if size of capacity has been reached, we need to increase the capacity of the array and copy. Over. So here, if the capacity is reached, meaning this number of elements is equal to our array capacity, then we will have to double our capacity, but at the cost of that, we need to copy everything over from the smaller array to the now larger array. And this will require O n time, n being the number of elements. So capacity, so we'll double it as I said before. And interestingly, the array list in Java, I think they increased the capacity by 1.5 times instead of 2 times. So that's just a little I don't know, fact, I guess. So now we need to create another array that has double the size or double the capacity. So we will do that. So we create a pointer to point to a new integer array with the size with the double capacity size. Right here. This capacity is now doubled. And now we need to copy everything over from the smaller array. And now we need to delete the old array from memory. Otherwise, we will have a memory leak, and that is not good. So delete the old array and set the array pointer to the new double capacity array. So now, so you gotta delete the old one and set A to point to the same thing that temp array is pointing to, which is the new array with double the capacity with everything copied over. And now we should increment the size of the array because we just added a new element. And now finally we need to add that element into our array. So we'll add it to the end. Okay, so now if the capacity is not met, if capacity has not been reached, then we don't need to increase the capacity, and we would just place it in as normal. Add integer into the end of the array. Init size -1 equals to add. Okay, so that completes our function of adding an integer to the end of the array. So our next function, or our next method we will implement is the get method, which will get the integer value at a given index. So it returns integer at given index. Returns -1 if okay, so if the array is empty, we'll return -1, and we'll let the user know. And then now the reason I included this std accept is because if the user tries to use a negative index or an index that's out of bounds, I'm going to want to throw an exception. Throws exception if index is out of range or index is negative. Now, as the programmer, you can handle this however you want, but so this is how I'm going to handle it. So, like for example, you can do if index is negative, or if index is or if index is out of range. You can also return -1 or tell the user. It's up to you, but in my case, I'm just going to throw an exception, and we're not going to catch it. We're just going to throw the exception. So now the first case is if the array is empty. We said we were going to return -1, so that's exactly what we're going to do. So if size is equal to -1, we should also let the user know that it's empty. So we will print into the console to the user that the array is empty. And then we return -1. Else, if now let's handle a case of if index is negative, they enter a negative index into the function. Then we should throw some type of exception. So I'm going to throw a invalid argument exception. And now if the index is out of range, so if the index is larger than size -1, then we throw a out of range exception. Index out of range. Now if none of these cases occur with the past index, then we will just return the value at the index. Okay. Next we will implement the searching function, and like I said, it will return index returns array index of key if found. So if the value that you want to search for is found, it will return its index location array. And keep in mind that it returns the first occurrence of the value you want to find. So say we had an array of 1, 2, 3, 1. 1, 2, 3, 1. If you wanted to look for 1, it would return 0 because at index 0 is the first occurrence of 1. So you would not get the 1 at index 3. So it's the first occurrence, keep it in mind. And then we will return -1 if the key is not found. So return -1 if key is not found. And I like this because it's obvious to the user that if you get -1 when you call search function, that something's not right, because the smallest array index is 0. So that is the reason why I didn't want to return -1 in these cases, because maybe they're thinking that the value they're getting at this index has the value of -1. So instead of doing that, I'm throwing the exception. But that's just what I'm. You can, like I said, you can handle it however you would want. So this is going to return an integer. Search. Oops. And we will take an integer parameter called key, which is what we want to look for. And before I continue, let's see if we can compile this. Good. Alright, so we have no problems. Alright. So what if the array is initially empty? So let's handle that case. So if size is equal to 0, then we should let the user know that it's empty. Array is empty, and we will return -1 here. Now if the array is not empty, then okay, and another point I want to mention is we are going to use a linear search for our searching implementation and not binary search. And the reason for that is because we're going to test it on a small data set, plus it's easier to implement linear search, and for our purpose it's not about searching implementation, it's about the dynamic array implementation and how it works. So for our demonstration, this just makes it a lot easier. But in general, you would probably want to use a binary search. So if you don't know what linear search is, it's pretty much what it sounds like, a linear search. You go linearly checking each element in the array to see if it's what you are looking for. So we're going to have to start from index 0 all the way to the end, or all the way to the end as in how many number of items we have, because there's no point going through the whole thing. Okay, so for integer I equals 0, I is less than size plus plus I. So if a at I is equal to the key, which is what we're looking for, then we'll return I, because that's the index of the item. Now if we go through this whole iteration, and nothing, this condition is never met, we come out of the else, and then we just return -1 to indicate that the value wasn't found. So, yeah, and I'm just gonna put a comment here. Linear search, easier implementation for demonstration purpose. I can make a video on binary search at another time. That's something that I'm interested. But so now let's create the printing function, because that's pretty straightforward. Print. This is a void function, meaning it returns nothing, and it will just simply print all the elements in our array to the console. So for integer I equals 0, I is less than size, plus I. Cout a at I space, and I'm gonna make it look a little nicer and create a new line for every 10 elements. So if I plus 1 modulo 10 equals 0, then we will print out a new line. Okay. Function print array 0. I'll upload this source code onto GitHub if any of you guys want it after the video. So let's compile this again and see that we have no problems here. And we don't. That's good. Alright, now our last function that we need to implement is the removal function. And like I said, we're going to remove items by integer value and not by index. And like I said, that this is a very simple method implementation. There are a lot of more methods that you could definitely add, such as removal by index, adding an index, and other stuff too, like combining two arrays together, etc. Like if you look into the array list documentation in Java, you can see all the methods, and same with the vector and C++. But like I said, for this video, it's just simple functions to demonstrate how you would implement dynamic array, how it works, and why you would use it over a normal static array. And you could think of, and it's also good to see how the array list or the vector works, and when you need to remove things, and every time you remove something, for example, it would have to do shifts of the values in the array. So remove specified value from the array. Okay, returns false if removal was not successful because the integer was not found. And we'll return true if we did remove the value. So returns true if the integer was removed. Like the adding case, or not the adding case, the searching case, it will only remove the first occurrence. And the first time it sees, say you want to remove 1, and you have 3 ones in your array, it will remove the one that it first finds. And bool dynamic array move integer to so integer location is what we are going to be returning, which is the index location of the item. Integer location is going to be the index of the item we want to remove. And so we are actually going to use our search function that we implemented to get this location. So we are going to search for the item we want to remove and place that index location into this integer variable location. Now, in our search function, we return -1 if it's not found. So we can use that to our advantage here. So we can say that if location is less than 0, meaning that it's negative, it's -1, then we know that the item is not in our array. So all we have to do is let the user know that the item isn't in the array and return false. Integer not found, removal failed. And return false here. Now, if the location is positive, then we know that it is in the array at some location. And now we have to shift everything over. Say we wanted to remove the item say the item to remove was at index 0. That means the value at index 1 needs to shift left into index 0, and the item at index 2 needs to shift to index 1, index 3 needs to shift to 2, and so on. So this will require, on average, n over 2, n being the number of items in our array. So it would have O(n) time, which is linear, which is not too bad, but it's still a costly operation. But that's what you're gonna have to do. So what we're going to do is loop starting at the location we got here. Because say the item was at locate index 1, we wouldn't start at 0, we would start at 1 because the items before it do not need to be shifted at all. So we start at integer I equals location. So we start the loop at location. And we loop up to the number of items in our array. So for I less than size, and we just do a at I equals a at I plus 1. So literally just replacing the current index with the value ahead of it. So we're doing a left shift. Pretty much doing a left shift. And then if you wanted to implement add a function that adds at a certain index, you'd be doing right shifts. But yeah, for our implementation, we just added an array to make things simpler. So once you have completed all the shifting, we will decrement size because we just removed something. And now, like I mentioned before, the dynamic array can take up a lot of space. So what we will do is once the capacity reaches floor, or once the number of elements reaches floor capacity over 4, then we will cut the capacity in half. So let's implement that. So if size is less than or equal to capacity divided by 4, then we will cut the capacity in half. And now I didn't write floor capacity over 4 because we are dividing by integers, and that automatically truncates the decimal. But if we're using doubles or floats, then you have to use floor to get rid of the decimal. Okay, so if size is less than or equal to capacity over 4, then we set the capacity to half of what it is. So capacity is equal to capacity over 2, and we create a new array with this half capacity. And like the increased in capacity, we're going to have to copy everything over. So for our new array, we'll iterate to the number of elements currently, and just copy everything over from A into the new array. And previously, we will have to delete the old array from memory and assign A to equal, or A to point to our new array. And if all of this goes through, it would end the else statement and then return true. So in Java, you would not have to worry about this, deleting the old array from memory to free up memory, because Java has a built-in garbage collector. So you wouldn't have to worry about that. But we're using C++, so we have to manage our memory. And if you did ignore this, as in did not delete the old array every time you shrunk it or increased the capacity, you would create a memory leak, and eventually run out of memory. Okay, so I think that's every function. So let's test. Okay, so let's test our function in our main class right here. So we will create a new instance of our dynamic array class, and we'll just call it list. Or actually, let's not. Let's just call it test. So writing it like this just calls the default constructor, which we have right here. And let's put 10 items initially into, actually, let's not. Let's put 20. Because our initial capacity is 10. So let's show that our array actually can grow by adding 20 elements. So, and we will also, in this case, use the add function that we implemented. So we do testarray.add to call the function. And what we want to add is, let's just add I times 2. So it would add 0, 2, 4, 6, 8, so on. And then we will also demonstrate the print function. So let's see what happens when we compile and run this. Okay, so as you see, we get our array printed correctly. We have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. And then it skips a new line because in the print function we create a new line after every 10 elements. And so 20, 22, blah, 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 so on up to 38. And you know this is correct because 9 times 10 is 38. So as you can see, even though we started with an initial capacity of 10, we did add 20 elements and we did print them. So let's test the other stuff now. Let's test the search. So let's say we want to search for the value of 19. We know this will not appear because it's every value in our array is even. So we'll call this search function here. And let's search for 19, and let's print this. Let's print this to the console. So let's just oh, I forgot to include iris thing. Okay, sorry. Okay, yeah, see. So here's our array currently with all values, and like I said, 19 would not be in here because these are all even numbers. So we get a -1 here printed because in our implementation we said to return -1 if the value isn't found. Now let's see what happens if the value is found. Let's look for 30 in our case, or let's look for 20 and 30. And as you see, it says that the value 20 is at index 10 and the value 30 is in index 15. So let's see if that's true. So index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, the value 20 is at index 10. Now let's look at 30, 11, 12, 13, 14, 15. So that is also correct. At index 15, we have the integer value 30. So that demonstrates that currently our print function, our searching function, and our adding function is working correctly. So now let's test our get function. And an easy way to test this, let's comment this out real quick because I don't want to display this onto the console, is to compare our test array print function and printing to the console just through a loop. You could actually just copy code here. Oh, and we can also use our get size function that we implemented here, because this is how high or how long we're going to the limit of our loop pretty much. Test array dot get size. So our get size function returns the size of the array. So we're only going to loop up to this point, and we're going to print by calling the get function that we create to get the value at the index I. So if this works correctly, if the get size and the get function work correctly, then this output here should be the same as output in our print function. And as you can see, they are both identical. So that shows that our get size function returns the correct size, and that our get value at index function also works correctly. And if you have used the array list data structure in Java, the function is also called get, and the parameter is also the index, and it does exactly the same thing. So that's fair and good. Now, what else do we have to check is the removal function. Yeah, let's just check it here. So let's just remove, for simplicity, let's remove just one item for now. And so we're going to remove by value, right? So if we remove actually, hold on. Let's remove 19 to show that it returns Boolean false if removal fails and that the value is not in the array. As you see, integer not found, 19 is not found, removal failed, and it returns 0. And if you don't know, in Boolean, true is 1 and false is 0, so that's why you have a 0 there representing false. And now let's remove, let's just remove 28 and see what happens. So remove 28. Get rid of this, actually. Look at that anymore. And we'll reprint the array using our print function. So as you can see, we returned 1 here in the, we displayed a 1 here, from here, 1 meaning true, which means that removal was successful. And if you compare the two prints here, starting at 0, you will notice that 28 is not in this print here, because it was removed. See, let's look, 20, 22, 24, 26, 28. So here it's just 26, and then to 30, when here it's 26, 20, 30. So 28 did get removed, and you can see that an element, it's size -1 because in integer there would be a value here. So it shows that removal does work correctly if it was found or not found. And now let's see what happens when we remove a lot of elements. So to make that happen, we will do a simpler case of adding elements. We will add, instead of I times 2, we will just add I. So, let's do that. So just show in our array, it should be from 0 to 19, which is the case. Okay, so let's remove, let's just remove 18 elements. And then we print. And as you can see, we removed 18 elements. 20 minus 18 is 2, so we should only have 2 elements left, and it's just the last two, 18 and 19. So it shows that our removal works correctly, and the capacity is reduced. The capacity does get reduced correctly, otherwise we would have some kind of problem here. So that's pretty much every function, and there is one thing I want to show before I end the video, and that's these two exceptions here. What happens when you pass a negative index or an out of range index? So let's take a look at that. Okay, so let's add I times 2 again to make it a little more interesting. Oops, that's called function. Okay, so here's our array. And now, let's say we wanted to print the array at index 0. Or let's say 1. This should return 2. And it does. So, now, let's see what happens if we want to get a value, but we pass in a negative 1. We know that that can't be right because indexes can't be negative. And here it crashes the program, and it does throw the exception right here of invalid argument and negative index. Okay? demonstrate. Okay, now what happens if we go out of bounds? So let's call it the getSize function to see how many elements are currently in our array. We know that there's 20 elements, but let's just see. So yeah, 20. Now let's say I want to get the item at index 20. That is going out of bounds because that would be the 21st value, or 21st item. At index 20 would contain 21st item. So we know that that would be going out of bounds. So let's do that. Test array. Okay. So we put 20, and it should crash and throw an exception like this. Yep. So it crashes, and it throws an exception of out of range and index out of range. Okay, so thanks for watching my video on dynamic array implementation, how it works, and why it's good, why it's bad compared to a static array, and comparing it to Java and C++'s vector and or ArrayList and vector respectively. I will try to make more videos in the future and hopefully make them better. Thanks for watching, and please like my video.